Good afternoon again. Let me welcome our next speaker. He is not very known in the open source community. He's not contributing to many projects. And no, I'm just kidding. So let's welcome Leonard Pottering and his portable services. Enjoy the talk.
Okay. Yeah, today I'm going to talk about portable services, which is something that we have been working on in the systemd project for a while. It's a step-by-step process, and yeah, the portable services concept is something where we want to go to. It's not where we are yet, but a good chunk of the stuff that brings us there is already implemented. So, what do I mean if I talk about portable services? In a way, the really short summary would be that it's system services. System services being the thing that everybody of you probably knows who ever touched a Linux system, a RHEL system or something, which is like a system service is really like a system 5-init script or a native systemd service or something like that. Plus some container features. Some container features meaning what that actually means in detail we come to later. But I don't know, like systemd, of course, doesn't live in a vacuum. There are many other things happening in the open source ecosystem, and the big one right now, of course, is containers. I mean, looking at the schedule of this conference, you can definitely see that. So, and yeah, when I look as a guy who's working on a service manager onto containers, I think that a good chunk of the stuff that they're doing there is actually pretty interesting and would actually make a lot of sense for service management too. So, and that's what portable services is. You could also say it the other way around, that it's a little bit like container management, but with a number of systemd service features, like system service features added on top, right? So it's something that if you draw the scale, is somewhere in between what a container is understood to be and what a system service is understood to be. So, a little bit more details. What are actually containers? I think very few people actually have a very clear idea of what containers are. Everybody thinks it's something very different. What I think it is, it's resource bundles, isolation, and delivery, right? And I'm pretty sure other people will disagree with that in some details and think it's more or it's less than this. But I think these are the three key parts of it, right? Resource bundles meaning you have one directory tree where everything's included, like your libc and whatever else. Isolation means you live in your own little world. You have PID namespaces, mount namespaces, and all these kind of things, so that you basically are isolated from the host system, and you live, yeah, in a completely different world. And delivery. Delivery meaning that, yeah, that somehow these resource bundles get onto your system, get deployed, and these kind of things. If you compare these three things with what portable servers are supposed to be, it's also resource bundles. But in contrast to isolation, it's integration. And in addition to that, it's sandboxing, right? Now you might ask what the difference between isolation and sandboxing, and that would be a very good question. In my opinion, isolation is really about creating a new world that is separate from the host world where you live on. While sandboxing is really, you continue to live in the same world, but you have less access to what the system provides than you would have if you would actually run the system. So that's my definition. I'm pretty sure other people would use different words for this kind of distinction. But yeah, so again, containers, resource bundles, isolation, delivery. For me, portable services are resource bundles, integration, and sandboxing. There's no delivery among this, because I think for me personally, that's not an interesting problem that I want to solve. I don't think that could ever fit that well into a service manager. I think that's something like how the stuff gets onto the machine is something that other people have to solve. What's really key about the portable services approach is that everything is modular, meaning that all the bits and pieces that put together this entire concept of portable services are separately useful, and you can opt in or out individually to every single one of them, and it's how the stuff is built, right? And it's not this weird thing where you get a shitload of stuff and then through some hacks you can remove some stuff, but it's really about being inherently modular, that you have a lot of options. So I already mentioned this range of integration. When I think about portable services, I think about a general range like where you have on one side integration, on the other side isolation, right? And if I would be a better graphics artist, I would probably have drawn it as a proper scale there, but I'm not, so you only have to do with this little bit chain of arrows here. So if you think about the scale and you put on one end classic system services, you have full integration, right? They run with full privileges, they get the full access to the host system. That's what I call full integration. On the other hand, you have virtual machines, right? Like KVM-like stuff, where you basically have, you run your stuff on the same system, right? But in most ways, it actually feels like could be on a completely different system. You are isolated as much as possible. There's no access to the process tree. There's no access to the file systems. And you basically, the only way you communicate with outside is through networking and nothing else, right? And then you have somewhere in the middle, you have something like Docker-style microservices. Nobody really knows what that is because some people run an init system inside of Docker and other people don't. Some things are shared and some things are not. For me, it's a little bit unclear what it's supposed to be, but it provides, on one hand, quite a bit of isolation because you live in a PID namespace, mount namespace, and all these things. But on the other hand, it also provides a lot of integration, right? Like, because you still, like, for example, on the host, you can type PS and you see the processes of the container. On the scale, I would also put something like full OS containers a la LXC or systemd nspawn, where you basically run something that is a real system that manages its own networking and everything, that feels a lot like a VM, but is actually implemented during container technology. And hence, yeah, it's a little bit more integrated than VM, but it's not properly isolated like VM. And then, yeah, the important part, of course, here is the portable system services, which I place on this scale ranging from classic system services to all the way to KVM. Somewhere on the left end, but not the very left end, right? So that you get some features that containers currently provide, but not all of them. So much really about how I would position, and so that you get a conceptual feeling of what I'm actually referring to if I talk about this. Now let's be a bit more specific. What do I actually mean with integration and isolation? So let's consider what's actually shared and not shared between the host and this program that you're running there in a container, in a VM, whatever you want to do it, or in a portable system service. So you could probably turn this into a nice table, by the way, where you show on that side, you show all these different things that are either shared or not, and on that side, you actually show the VM, LXC, nspawn, and these kind of virtualization solutions that you have. For example, networking, classic system service, of course, share the entire networking with the host, right? They live in the same network namespace traditionally, and if you type ifconfig on the host or IP adro, whatever you want to run, that's the same thing that the server sees. On the other hand, if you do VMs, that's totally not shared. You live in your own world. You have a known IP address and everything. If you think about the file system, classic system servers share that. VMs really don't, and Docker kind of doesn't. PID namespaces, Docker generally has that. Classic system services do not. The init system is usually shared, like the most common way how people use Docker is, of course, that they do not run an init system inside of it, so it kind of Docker is the init system, or the host side is the init system. Device access is something, yeah, of course, if you have classic system service, you have full access to all physical devices. VMs do not have that, except if you jump through some hoops and virtualize them and give access to them. But it's not natural, right? Docker kind of tries to optionally give access. I personally think it's really ugly to do that, but sure, people do that. Logging tends to be pretty nicely integrated with containers, and totally not with VMs. But yeah, anyway. So I don't really want to go into too much detail, like actually tell you all the possible implementations with exact feature sets. That's really out of scope. I just want to position the portable system services here. And yeah, for the portable system service, networking is shared. The file system is mostly isolated, but can also be shared in parts. PID namespaces are not used, so the PID namespace is shared. The init system is shared. The device access is shared. And the logging is shared. So on these points here, you get full integration. By the way, I know I talk pretty fast, and if I talk too fast, just show up and I'll try to slow down. Can't promise I'll keep that on for long, but... And also, if you have any questions, I very much prefer if you interrupt me right away than just doing questions at the end. So if anyone has a question, totally interrupt me. Anyway, so much really about the positioning what portable servers are supposed to be. Now let's talk about specific goals that I want to implement with that. So I mean, again, I'm a service management guy. I'm one of the guys behind Systemd, of course, and Systemd is at its core a service manager. So the way currently services are deployed is that they, like unless you use containers, is that services leave a ton load of artifacts on the host system, right? If you install an RPM for HTTPD, then you get directories created everywhere. You get a system user created. You get all kinds of stuff ends up being hooked into the system at various places. One of the goals with portable system services is that that's a thing of the past, right? So that there are no artifacts left in the operating system when you install a portable service when you remove it again. This basically means that the life cycles of things are bound together. Like, for example, the temporary files you create in /temp, or the system users you have, that their life cycle is actually bound to the life cycle of that portable service. As long as that portable service is running, these things are allocated. As soon as the portable service is stopped, these things cease to exist and don't pollute the system anymore. I mean, this all to a certain level. Like, for example, logs you probably don't want to kill if you uninstall a portable service, but pretty much everything else you do. Another goal, which is obviously shared with containers, everything in one place. Meaning, it's kind of the other side of the leave no artifacts thing, is, yeah, things shouldn't have dependencies and things should be self-contained, meaning that the directory tree where you ship stuff has everything in it, libc, configuration files, everything. Another important goal that I really care about is that I think portable service should just be a special case of normal service management, meaning portable services should feel like native services. It shouldn't be a difference if you actually install HTTPD as a traditional system service, right, with full privileges in the same namespace and everything, or if you use one of the new modern portable services where it's completely exposed the same way, except that sandboxing is nicer and you ship it a little bit different. So yeah, specifically this means system control should work the same way for native services as for these portable services. So why all this? It's always the question to ask. For me, it's the next step for service management. Looking around on how people actually use containers these days, I see that, I mean, a good chunk of how people use containers, I have, in my opinion, is probably something where they shouldn't actually be using containers, right? For example, Red Hat has a lot of talk about highly privileged containers. I personally think that's a weird concept, like, because if you use Docker, then it's about isolation. If you then turn off the isolation, then maybe you shouldn't be using Docker. So I think it probably would make a lot more sense to go from a service manager level and just add a couple of things to make this useful for this use case. And yeah, for me, that's the next step of service management. Service management being at the core of what Systemd does, it appears natural to me to make it better. Something that I also think is pretty interesting is the metadata, right? It's really difficult to like for example, if you would start a new container manager today, a lot of stuff is already prepared for Docker. So how would you ever compete with that? Now the interesting thing is that everything already has a Systemd service file. So to me, it's really interesting to just say, given that Systemd is kind of like has reached the goal that most of the commercial distributions have adopted it. There are Systemd unit files for pretty much everything, and I think at this point in time, administrators, users have actually understood writing them and reading them. So one of the goals that I have with this is saying, let's not introduce any kind of metadata, just extend a little bit the metadata that we have, which is Systemd service files for me. Yeah, so that's kind of the same thing here. Admins are already used to services, right? And it always appeared to me strange if they have two levels of management for everything, right? So that the system level stuff, they manage with system colon these tools, the container stuff with something completely different, right? So to me, I think it should be a goal to like abstract that. That doesn't mean that I want to take over the container world. I really don't. But it does mean that things like, I don't know, resource management should actually be the same for system services as for these containerized things. So, yeah. And I already mentioned the super privileged container thing. I think what these portable services could perfectly provide is the concept of super privileged containers. Super privileged containers, again, is this Red Hat thing where you ship something as a bundle and then it runs with very high privileges, seeing a lot of functionality from the host system that's normally not available to a container. Yeah, and then one more thing here is integration is good, not necessarily bad. I mean, there are cases where it's awesome to have your isolation for everything, but there are also cases where integration is a good thing. For example, I mean, most of the actual applications that are deployed in the world usually don't consist of a single service, right? There are a couple of services that work together. And if you want to run a couple of services together, there needs to be some kind of interfacing. If you isolate everything to the last bit, then this kind of interfacing usually boils down to networking. But networking is great, but of course it creates its own set of problems. You need to actually manage it, right? Like you have to, the low-level network management of the host, and then you put another layer on top so that the containers can talk to each other. So I think actually, in order to keep things simple, in many cases would be highly beneficial if you can get that integration that you want without having to fiddle with all these things. One example, for example, you have one portable service that runs Apache and another one that runs MySQL, and would sometimes be nice if it would be natural, right? If they could connect to each other via Unix socket and var up MySQL, run MySQL, right? So, yeah. I mean, again, this is what I think, like it's a reasoning why I started the portable services stuff. It doesn't mean that everything that people do in containers is that way, absolutely not. There are a lot of reasons why you really should be using something like Docker. But I also think there's a lot of stuff where people are trying to turn Docker into something that it probably shouldn't be, and where I think the portable services stuff would be a good alternative, and at least one that I think is a little bit nicer. So, let's go towards the actual, how portable containers actually really look like in real life. So one thing that I really care about is that systemd in the longer run knows 3 service formats natively. And the distinctions between the 3 are hidden away as much as possible. That is, first of all, system5 service files that you might know from RHEL 6 and other Linux distributions, or Unix things. There are native systemd service files for native services that are shipped in RPMs, and now these new ones, the portable ones. My goal really is to make sure that whatever it is, it shows up the same way. So you type system control, you see them now. You type system control enable, you enable. System control disable, you disable. It should all work the same way, exposed with the same semantics, have the same dependencies, have the same resource management ways. Your system control set property should work for them, and these kind of things. It shouldn't matter where that service actually comes from, in which of these 3 formats it comes. Now, while these are the 3 formats that I will care about in systemd natively, the goal with all the portable services stuff is actually to be open so that the individual building blocks can be used to build something completely different, right? So, giving credit to that, you can actually build a generator. For those who don't know generators, generator is a systemd concept that basically allows you to translate at boot foreign configuration into native systemd units. This is, for example, how systemd implements compatibility with etcf stab, right? Because etcf stab is the classic Unix way how you configure your file systems. And to integrate that into the systemd dependency tree so that, the block devices show up, your file system check, and so on, we have this generator called fstab generator, and it turns this information into native unit files. Now, we have quite a few generators by default. For example, System5 service compatibility is implemented the same way. It looks through the System5 directory, it looks for all the services, and generates native systemd services. Now, with the portable stuff, it's going to be connected the same way. So that, basically a portable service you just drop somewhere and the generator turns it into native stuff so that you cannot actually distinguish it from a native thing because it is a native thing. And the idea is that these building blocks for the sandboxing that systemd will now provide, together with these generators, permits you to hook any kind of system to the scheme that you like. For example, you could, and some people are working on that actually, write a generator that turns OCI stuff into native systemd unit files, so that it doesn't really matter what you have, what you actually want to run, as long as it's something that you can turn nicely into a systemd unit file. It can be managed with systemd and the rest of the tools, in every possible way. So, portable services on the technical level, like on the implementation level, for me are basically services that ship all their stuff in one directory or in one disk image or whatever you want to call it. What's important to me is I don't really want to define any new formats here, because I don't think I should be really in the business. I have defined my own format 5 years ago with a systemd unit file, and that's what I want to build on. So for the portable services approach, what really matters is I don't define new formats on disk. I don't define a new OCI standard, what's it called. I just say portable services can come in whatever you want, as long as the Linux kernel supports it. Specifically meaning either it's a simple directory tree, right? You put it somewhere, and then systemd can run that as a service. Or you can have a complete disk image. Like, for example, a GPT disk image that contains a squatchfs, or something like that. It could be an ext4 without a GPT or something like that. What really matters, though, is it needs to be accessible with Linux functionality directly natively. That's what I care about. Implemented is this in systemd like that you have in unit files, you have a new switch. Or actually, the root directory switch existed for a long time, but it's a lot more useful these days. And basically allows you to say, yeah, run this thing, but use this directory as root directory. And then there's root image, which works like that, where you specify a raw image file instead. And then what actually happens in the background is kind of nice. We'll automatically set up a loop device. We'll scan the partition table of this. We'll mount it nicely and run the stuff from it. It's actually really cool these days what systemd can do there natively, like because it has dmverity support and all these kind of things. So it can automatically do integrity checks while the service is running and things like that. It's something which, by the way, nobody else can do who does container stuff right now. By the way, anyone has any questions? I'm talking a lot here. Can't believe really that nobody has any questions about any of this. Or nobody dares. Anyway, let's continue. So these disk images, the approach here is, I mean, on Unix, we had chroot since a long time, right? Like when I started with Unix, like with Linux, I ran qmail in a chroot, right? And there was, I don't know, 1994 or something. And containers are not that new. They use that concept that was already established back then in a nicer way, but still, it's kind of the same thing. So, yeah, but the problems that chroots traditionally have are still there today. So with this approach here with the root directory and root image settings in systemd, we try to fix those. What specifically that is will come on a later slide. And I already mentioned that the root image thing that we have in systemd for services now can do crypto and verity and all these kind of things. That's a very good question. Okay, I should repeat the question. The question was regarding whether these portable servers are actually portable to other operating systems. And the idea, of course, that they are. But then again, I'm not the guy who will give promises, because you ultimately, much like containers, you give the guarantee. If you would actually give the guarantee, you basically say the APIs provided will be the same on every single operating system. And like for containers, the primary API that you're talking about there is the kernel API. The kernel people have been relatively good at providing stable APIs, but they really, in real life, actually didn't. So I don't know. I don't consider that part of my business. It's like, yes, they should, in theory, as much as containers do. But I will not give the guarantees. I know that Docker people actually, they kind of want to give that guarantee. I think they shouldn't, because it's outside of what they can do. All I want to guarantee is that the surface, the compatibility surface, is as minimal as possible. Meaning that when you run something as a portable service, you see from the host system by default as little as possible. You get your own directory in /run, your own directory in /varlib, varlog, and a couple of other things, but nothing else, right? And then you opt into additional stuff if you actually, for example, want to access the varlib MySQL socket, you get to do that. But the idea is really minimize everything and then hope for the best, given that the kernel people have a relatively okay reputation for the compatibility. So the question was whether this minimal level is just a kernel or is it kernel plus some other APIs. And well, I mean, systemd doesn't really provide APIs there for the application. I mean, there are very few APIs like SD-Notify, if you know what that is. SD-Notify is like it's a concept how services can notify systemd. But that's an API that has been stable as long as it exists, and exists like 5 years. So I think, I mean, it's a very minimal API. It's just sending out a message. So that stability, yeah, I'm happy to guarantee. But other than that, we don't really provide much API. We don't have a REST interface or so from the host to the client. So I think we should be pretty good there. It's only really the kernel plus very minimal other things. No other questions at this moment. OK, so let's talk a little bit about sandboxing for a moment. Right? I mean, something that, again, containers provide you with is all this isolation. If we don't fully isolate things, then we at least should be able to provide sandboxing, meaning that it's mostly about, yeah, that you still live in the same environment, as I mentioned earlier, but you have less access to things. Now, in the past system releases, and in the yet to be released 2.3.2, we have added quite a few different sandboxing settings to systemd unit files. These settings are completely independent, actually, of portable services. The only reason why I put them on the slides here, because they become extremely useful as one part of the portable services concept. Now, the ones that I put on here, I don't really want to go too much detail what they actually do. I invite everybody of you to actually look up at the man page and look what they do, because even if you don't live in a portable services world, it's all options you probably should be turning on if you manage, if you maintain a service on Fedora, because it actually allows you to reduce attack surfaces drastically. So, for example, there's private devices, which gives you a private/dev for your service. So, which only contains dev uren and dev null and these kind of things, but does not contain actual physical devices like dev SDA and these kind of things. There's private network, which basically means that you live in your own little network namespace with only a loopback device and no connectivity to the outside. There's dynamic user, which is a relatively new thing that I actually want to talk about if I have the time later in more detail. It's about, yeah, let's talk about that later. There's remove IPC, which is basically something where you can bind the existence of IPC objects on the system to the lifetime of the service. That specifically means POSIX and System 5 IPC, like semaphores, message queues, and these kind of things. There's private TMP, which gives you private/tem. There's private users, which basically allows you to disconnect the user database of the container or the sandbox environment from the host. We'll talk a little bit about that in more detail later. There's protect system, which basically allows you to make sure that whatever runs in your service does not get write access to anything on the host except what you want it to be. Protect home it's kind of same thing for /home. System call filter is a very powerful way how you can reduce attack surface on arbitrary system calls. It's actually pretty useful these days. Originally it was pretty boring because it was just really a list of system calls, and nowadays has these groupings and things like that. Restrict address families is actually really awesome. It allows access to specific socket address families. So you basically can say, yeah, this service shall get access to the internet, but not to Bluetooth and Netlink and whatever else. There are a couple of other ones, like runtime directory is kind of nice, because it basically says that your service gets its own runtime directory, which is lifecycle bound to the service itself. There's restrict real-time, which basically says that your service can't get real-time scheduling, which is a pretty important thing, because real-time capabilities are granted by default on Linux to privileged code. And if you have that, you can make the machine hang. Protect kernel modules basically takes away the right to discover and load kernel modules, and a couple of other ones. There's more to come, like the ones I put up here. that allow more sandboxing, where you can basically disconnect something from the kernel log so that they can't see the kernel logs, like demask, meaning protect clock, so that you can disconnect it from being able to change the clock. And a couple of other ones, protect tracing, protect mount. I think most of this is pretty self-explanatory. Data directory, cache directory, and log directory is something that is particularly relevant if you, as we talk about dynamic users, and we'll talk about that briefly later. Something that also ties into these that we have been working on is per-service firewalling and accounting. Meaning, I mean, we have all this resource management and sandboxing for everything else, but not for the network so far. Daniel Mack, like one now ex-Red Hat guy, has been working on making it possible that we can do per-service firewalls so that he can actually, on the network, also lock down specific services so that he can say Apache gets access to the network, but I don't know, my local udisk daemon does not. And accounting at the same time, because, I mean, to be able to put limits on things, you actually need to know what the thing is actually using. So what's really important, though, is for portable services, all the sandboxing stuff that is shown here, plus a couple of others, will be opt-out, not opt-in. Meaning, I mean, it's something that we probably should have done if we had all these features from the beginning. We should have done for all systemd native services right from day one, because, of course, security is always better if you default to having it as tight as possible and then permitting people to punch holes. Then the other way around, after all, security is not an enabler, it's a disabler. So if somebody puts together a service, it's like, it takes, he must be actually interested in security to enable all the security features. So for the portable service, since they're new, we can turn them on by default and then ask people to turn them off. At this point, any questions?
So what if we later come up with new hardening features?
Very good question. So the question was regarding what happens if we come up with more sandboxing features later on. And that's a very good question. I have some ideas what we can do about this. Like the general problem is basically that if we have the tightest possible sandbox for portable services from day one, and then later on come up with other ways to sandbox things, if we then basically later on enable those too by default, then the services might break because they actually needed that functionality. So you always have this problem. What you do there, one of the ideas is that you basically write into the unit file, I want this level of protection by default or something. But yeah, we have to figure that out. It's all solvable. I don't think nothing is pretty about solving it, but it has to be done. So yeah. Any questions at this point? So let's come to the actual hard problems about all of this, where things become nasty. One of the things is dynamic users, right? If I have a system service, like Apache, and I make it a portable service so that I can drop it into my system, then it should traditionally HTTPD runs as a user HTTPD or something like that, or WW data, or depending on the distro you have. Of course, that's hard to do if the service just is dropped in and shall leave no traces on the system when you remove it again. That is because traditionally in Unix, users have to be stored in etc path WD. And hence, and especially in RPM, right? Like if you install HTTPD on a system, and then you get a user created in etc path WD, and it's never removed again. Even if you remove the RPM, the user doesn't go away. The reason for that is because on Unix, ownership of files is sticky, right? Like if something created a file somewhere at one time, that file stays owned by it regardless if the user goes away later. And then if the user ID is recycled, something would get access to that probably should not have. So if we want to do unprivileged portable services, we have this problem. What do we do for the users? The concept that we came up with in systemd is dynamic users. It's a simple Boolean that you can set. If you set it, then a user will be created that lives exactly as long as that service is running and goes away the instant the service dies. Now, the stickiness problem. How do we solve that? What's already implemented is the following. First of all, as soon as you turn on dynamic users, automatically your service enters a sandbox where it will still see the rest of the system but cannot write to any of the directories. Like this is like dynamic user, by the way, outside of this immediate scope, again, of portable services, you can use dynamic users for any kind of service, actually. Right? So by simply turning on dynamic users, you cease getting write access to anything, anywhere, right? So that's a very efficient way to avoid the sticky file problem, right? Like, because if you cannot create a file, you cannot create a file by the user ID that goes away way later. Then there are two ways out for it that are already implemented. One of them is the service will get its private /temp and var temp subdirectory. So that's a place where it can create directories. And the trick is simply that directory gets lifecycle bound to the lifecycle of the service. So yes, your service can create files there, but you also know the instant the service goes away, those files go away. Something similar is done with a runtime directory, meaning in /run you get your own private directory where you can put your sockets, whatever else you want to put during runtime there. But that directory is as well lifecycle bound to the service as long as it's running. Now, that solves a big deal of the problem, but it still has the problem, yeah, you can't leave persistent files around. Or if you do, and you could figure it that way, then these files will be owned by a dynamic user that existed at once upon a time and might not later. The approach that I came up with there, which is actually not yet implemented, but I think I figured out, is going to involve doing a little bit of bind mounts and having a top-level directory where we can put the dynamically user-owned stuff so that the systems on the host cannot access it except for the containers themselves. I don't really want to go into much detail about this because it's a very low-level question, but it's a topic. But if anyone has a question about that, you can talk to me later. So yeah, dynamic users are a problem, but I think we solved them, well, except for the thing, the persistent file, which I'm still working on. But conceptually, they're solved. The other problem is, of course, user database mismatch, right? If you allow these portable services to run on the host and live in the same PID namespace, then you see everybody else's process. And traditionally, since time began with chroot, that means that the user database inside of the chrooted environment and on the host will, if they differ, you have a problem, right? Like, because if HTTPD inside of such a chroot environment thinks that HTTPD has user ID 50, and on the host it thinks it has user ID 61, then it's already a problem, but the other way gets much worse if you actually have the same user ID being used by something else. So the approach I came up with to deal with that problem is by using, like introducing an option that I already had in my slides earlier here, which is having private users Boolean. The private users Boolean basically detaches the user database from a service from the user database of the host. Specifically meaning it will set up a user namespace. I'm not sure if anyone of you know what a user namespace is. User namespace basically sets up an entire new user ID environment. Now, the user namespace that this sets up is special in the regard that it will actually map everything to the user nobody, except for the root user and the user the service is running as. That basically means that only two or three user IDs actually need to match. One is the root user. Thankfully, all Linux distributions tend to agree what the user ID of that user is. It's 0. It's kind of, required by the kernel. The other user ID that most distributions can agree on in one way or another is the nobody user, because that's 65539, whatever. So everybody agrees on that, though some distributions give a different name, like Fedora, Red Hat. We are pretty bad at that. We call it NFS nobody for stupid reasons. And the other user ID that actually needs to match is the user ID that the service itself is running as. And that's what this private user setting actually does. It will set it up so that it doesn't matter. The effective difference meaning is then that if you look at the system from inside the container, you basically see all processes, everything that's running, all IPC objects, either owned by root, or owned by nobody, or owned by yourself, but by no other users. Right? So if I'm logged in as on my machine, run Firefox as user Leonard, that service where that's turned on will see Leonard being owned by nobody, and that's kind of the point of it. I hope you could follow about the concept around this. Now, having dynamic users and the user database mismatch is a problem that I think I mostly solved in this regard, but it actually spills into a lot of other things. Like one major problem is dbus, for example. Dbus does policy checks on user IDs, and if your user IDs aren't sticky, you have a problem. And specifically because also the policy around dbus is actually not stored, like it's stored in the system in one special configuration file or one set of like a directory. And hence doing portable services that provide dbus services, which I think should be absolutely the norm, is highly problematic because right now it means modifying the host system. And that again is directly contradicting my goal of not leaving artifacts around in the system. So I'm working on that. That probably will take more time to actually get fixed. The approach that I'm trying to follow up there is that essentially rewriting dbus into something where the policy is encoded at the same place where the service definition is. So much a little bit of the details. I don't know. I'm talking mostly about concepts here that half of them are implemented, half of them aren't. Let's talk a little bit about what's in general in the scope for the project. It's definitely it's simple delivery, meaning that not really deployment, but pretty much to the level where you do HTTP. It's verification, simple building, versioning, socket activation. What's out of scope though is load distribution, migration, fleet stuff, cluster deployment, claim we define a universal API, like the question that was asked there. Server-side functionality and desktop stuff, right? That's kind of out of scope for it. Now to give you a little bit of a feel where this all should be going so that you actually get having a feeling what am I doing there actually. I put a couple of command lines that they are not real, right? Like you cannot actually run that, but the goal is that eventually you can. And the idea is basically that you can issue, do you actually have a laser thingy in here?
Yeah, the red button.
Woo, what did I do there? Oh yeah. So the idea is really that you type system control start, and instead of specifying just a service name, what you do, you specify a URL which points to I gave this the PSI suffix, but that doesn't have to stay that way. I don't know what we'll do there. In this case, this could be, for example, a raw disk image that contains a scroshfs or something like that. And what this does really is it will download that thing and run it, right, as a portable service. That's kind of the goal that I want to go for. And then after you did that, you can issue system control status foobar, and it's because it's a portable service and it's directly integrated into systemd like any other services. You can issue system control status foobar and it will look exactly like it otherwise would. You can stop it then afterwards after you install like that, and this is where it gets more interesting. There would be a new command system control purge so that you can drop the portable service, which of course does not apply to native systemd services because they are removed with RPM. And then another command line to make it more interesting is that you do the same thing, but actually run it on a different host. Like this kind of already exists, like the -h, but it gets a lot more interesting if we actually have the other part here that you can have this kind of simple thing here. Now, the other thing would of course be that you work on something, you package it up as a PSI, and then run it like this on another host. This is all the slides that I have. I know that this talks a little bit more about, usually I try to prefer doing talks about stuff that I actually did, and less about stuff that I plan to do. This one is half-half, I think. Well, let's say 70-30. But I hope you got an idea what I have in mind there. The question, of course, is how all of this relates to, I don't know, more traditional container management. I think for many use cases, this might be an interesting option to use instead. I think given that the building blocks, like all these options, the sandboxing options, the root options and these kind of things are all individually useful without actually buying into the portable services stuff. I think it's extremely useful, for example, to write alternative generators that generate native unit files that run something else, like for example OCI and these kind of things. The key here really is to have something that people can extend, can build on, but that service management ultimately is something that becomes reusable in whatever way you like, and the sandboxing functionality systemd provides, so that, we put the tools in the hands of people to build what they like, and we'll provide a basic implementation that makes things work nicely for people, but just to give a demo, but what actually people build from it is up to them. Anyway, I think my time's, I got like 5 minutes or something. Anybody has any questions about my talk?
Distinguishing it all between privileged and non-privileged services. In a systemd unit file, it's pretty easy to run arbitrary code and screw in, not full privilege. So with these PSIs, do you imagine that a PSI author could have full access to system unit files? You said it would be opt-out, but is there going to be any distinguishing between what level or what
So I'm supposed to repeat the question. The question is whether there's how that actually works, I guess, with the privileges that you pick for a PSI, right? Like if we support unprivileged as well as privileged things. This stuff is mostly focused as running system services, right? It's not so much on user stuff. It's not desktop stuff. It's system level stuff. And the idea is that you basically run everything as tightly controlled as possible, but I don't think I should be in the business of prohibiting people things. So the idea is that people start with the tightest sandbox possible, but it's completely up to them what they write into their unit files and how many holes they punch. And if they want to punch holes into everything and just disable all kind of sandboxing, they are welcome to do. I'm not the policing guy who will prohibit that to do them. So yes, while we do default to sandbox as possible, I absolutely intend for people to pick whatever they like, and that's kind of the reason why I think this is actually appropriate for the super privileged container stuff, because people can pick exactly what they want, and I want them to, and I don't have any philosophical backing that I say, no, don't do that, because I say, yeah, portable service is ultimately the same thing as a native service. It's just one that comes with nicer defaults that I think are nicer, ultimately. I hope that answers the question. There's a question.
What you said about dynamic files.
Dynamic users?
Pardon?
Do you mean dynamic users or dynamic files?
No, you said dynamic stuff, like temp files, temporary.
Yeah.
That should go away once the service is stopped. So that sounds a bit like you had a union file system, and then you just removed it altogether, while still having access to the underlying file system, like libc. And then the example of that squawk is that, having a DCT and then you probably will not see libc itself. How does it compare?
So the question...
The option that you have an option that you either use as much of the system that you need,
No.
or you have a complete isolated file system.
So I'm supposed to repeat the question. That was like how much I actually reuse on the system. I don't reuse anything from the system, actually. Right? The idea is that, like, if you buy into the full portable services thing, right, then you use root image or root directory, and then you ship all this stuff the way you want, and there's nothing reused from the system. But you have the option to whitelist stuff from the system that gets made available to your container. But that basically means, that some directories in var lib that are available on the host are also mounted into the container, right? But ultimately, there is no reuse. There is no use of overlay FS. There's no use of anything like that. You live in your own world, and you get a couple of things whitelisted that are also like that are from the world outside of you, but they're also made available the same place that they're outside, if you follow what I mean. So no overlay FS, no kind of trying to reuse anything. This is about system level stuff. So I don't intend this this is not a world where you have runtimes and things like that. This is really a world where you ship everything, and that's the price you pay, basically. Okay?
When you install native services from RPM, the dependencies are managed in the RPM. How do you manage dependencies for portable services if you install them from PSI?
So I mean, so the question was regarding dependencies, because RPM manages dependencies, and the question is what happens if you use this. Of course, the idea with containers, the original one at least, was that there would be no dependencies, right? So that everything, you merge all your packages into one big blob, and then there are no further dependencies. Of course, in real life, that's never going to be that way, because things are interdependent beyond that. Systemd has a dependency engine. right? In systemd, if you have one service and you have another service, you can order them after each other. You can require them each other and these kind of things. So again, the goal here really is not to introduce any new metadata, but simply build on the metadata that we already have in the system unit files, because they actually can express all that pretty nicely already. So that would be my answer. But again, a package manager and a systemd service manager is kind of different things, because my dependencies are runtime dependencies, and the dependencies that you come from are more like installation dependencies, right? But yeah, the installation dependencies answer to me like that I would give you would be there are no, and that's the idea of containers, that you ship all this stuff along with your image. I hope that's an answer. How much time do we have? I don't have any time. Thank you very much. If you have any further questions, meet me outside.
40 minutes, right?
You have 40 minutes for talk and 10 minutes for Q&A. If you want to change
40,
it,
40 minutes to
40 minutes to talk and 10 minutes to Q&A.
Okay.
So 15 to